to change the network type, and we need to change it from distance-based to a ring lattice, which is the third one in the list there. Okay. Now, you'll notice that when we do that, just below it, the parameter area changes. Okay. So I don't know if you saw that, but let me emphasize again. I'm going back to distance-based, and you'll notice this connection range is enabled. We can fill that in. If we go up to ring lattice, only connections per agent. So it's basically enabling and disabling ones as to whether they're germane for the particular network type. Here, the salient parameter, the only parameter on there which makes sense, is how many connections do you have per agent? In other words, each agent is assumed to be connected with a certain number of connections on either side of it. And how many do you have? We're going to start with 2, and we can futz with it and see the effect of more connections.
So the other parameters are not used, right?
Right.
So they're just there for...
So they are there if you want to switch to other networks. They won't be wiped out.
So it's just for convenience.
It's for convenience, and so that...
It's not like it's assumed 100 or something. It just doesn't make us change things.
Correct. That 100 has no operational meaning right now. And what it does mean is if you were to go and switch over to one where it has an operational meaning, like distance-based, and change it, and then switch network types, it will still remember it. It doesn't toss it out, but it grays it out to show it's not operational. Okay? And I think it's, generally speaking, it's to kind of afford you a way of quickly changing network assumptions and seeing the effects without forgetting your parameters. Yeah. Okay. So we're doing ring lattice here, and I'm going to do 2 connections per agent. And let's run this model. Okay. So we're going to go and we're going to run it, and what we're going to see is that, well, we see something that's not terribly instructive. And I did this by design. What is notable about this in terms of how it differs from the last one? There are some differences from the last one. Can you enumerate a couple? Let me count the ways. Let you count the ways that this differs. Okay, everyone has 2 connections. That's key, and that's arguably the most important property. What else is different about the nature, the spatial nature of those connections? They're very long range. In fact, there's no particular preference for short or long range connections. They're kind of haphazard in their length, right? There's some short range, there's a lot of long range ones. Whereas previously we had distance based, which was by definition all shorter range connections, right? Okay, so this is a ring lattice, but you'd have to take it as, yeah?
Can we also infer that all the agents are connected now because in the previous network they saw some isolated agents that were not connected, and in this network they must be.
This is correct. They are all connected. By its nature, they are all connected to one another. However, the visualization there was singularly uninstructive for helping you understand that connectivity, to help you to prove that these are all connected, and indeed that the infection could propagate to them would require a lot of sort of eye squinting, to say the least, right? Now, I was musing about the idea of having you time this, time sort of the infection spread here. I'm actually running this out, and take my assurance right now that these are all connected. We'll see a kind of visual proof of it in just a moment. But do you notice anything about the relative timing of this compared to that distance-based network? In terms of how long it's taking for more or less the entire network to get infected? Taking longer or quicker? Taking longer. It actually takes a lot longer, and we'll see why in just a sec. Okay, so it seems to, visually have a few differences, but to really bring those out more strongly, we have to appeal to this layout property. So we're going to go up to environment again. That's where we dictate not just the network type, which we just changed, but this layout type. So specifically, I want you to draw down from user defined, which is here really just meaning the default one, since we're not overriding it in any way, and pull it down to ring. Okay. We're going to call this up and run it here. The ring of truth, forsooth. So now we have a depiction of the same logical network, but depicted so that the spatial layout and the visual layout, again by extension, helps you understand the connectivity, right? And what you see is that the infection is spreading, but it's spreading very slowly. Why is it spreading slowly? Why do I say that at a qualitative level?
You can only spread to your direct neighbor.
Yeah, there's no shortcuts, right? There's no shortcuts by which you can jump kind of across the pond, so to speak. If you're gonna spread, you can only really spread along one dimension. Now that's in contrast to the two-dimensional distance-based network, where you can spread in 2 dimensions, right? So things could spread more quickly. Here you have to kind of thread through this long circuitous route. Well, it's not terribly circuitous, but it's long. And finally it's going to get over there, but it takes quite some time. So this is a visual depiction that helps us understand that structure of the network. Mind you, however, that we've done something with a certain measure of import if your model cares about space, because here people are arranged not just visually but in space according to this ring structure. Okay, so that is dictating their spatial location. So if we were to ask about their spatial location, it's dictated by this ring. Now here, our model doesn't care about spatial location per se, so it's not really germane. But be aware that that visual layout does come about because we are changing the spatial location. Okay. Okay. So there's no shortcut, and this ring lattice network type is most naturally displayed with the layout type. I mean, logically it works without laying it out that way. It's just it helps you really understand what's going on in terms of locality of spread if you show the layout type. So this was without the ring layout, and this was with the ring layout.
Give an example of using this ring lattice model.
I'm sorry?
What is the example of ring lattice?
Well, it's an extremely common sort of stylized model where you have essentially very, very local connections, and you're interested in understanding how network structure impacts the dynamics of the network. This is an extreme. This is like the most extreme network you could still have that's still connected, but you have no global structure. And then what we're going to see is that there's a flip network called a Poisson random network that's the opposite extreme. There we have basically no regard to whether things are global or local connections. In a way, everything is global. Everything, you're just connected with random people. And so often we examine the dynamics for these two extremes, and we contrast them to understand how does the network structure impact those dynamics. So it's not so much that the ring lattice is an inherently good representation of how things are in the world. It's just, it helps us understand how does the network structure more broadly affect things. Now, that being said, there may be cases where you have, a spread of Ebola in a subway tunnel or something like that, where you might arguably have, sort of a more or less 1D spread of things. But for most part, it's very stylized. Okay. Okay. So now let's go to Poisson random.